This is video 2 for the maxima and minima section of, so it's chapter 4, section 3 in your calculus book. All right, so I've got two definitions, well, a definition and a theorem here. Both of these are from page 386 in the book. So our definition, let C be an interior point in the domain of F. So an interior point means not one of the endpoints. So if your domain goes from -1 to 1, we're not looking at the point -1, we're not looking at the point 1. Any other point between those would be fine. All right, so we say that C is a critical point of F if F prime of C equals 0. So if we take the derivative and the derivative at that value will be 0, or if F prime of C is undefined. So if we have a situation where we plug C back in and we get something that's undefined. Fermat's theorem, which is theorem 4.2, the proof of which is in your book. So if you want to look at it, you can. I'm not going to talk about it here. But the theorem says if F has a local extremum at C and F is differentiable at C, then F prime of C will equal 0. All right, so a couple things. First of all, the local extremum, that means a local min or a local max. So if you look below in that A, that local max at C has a derivative at C to be equal to 0. So that's an example of where Fermat's theorem is working. The other important thing, it's if F is differentiable at C. So if you look at B, there is a local maximum, but F is not differentiable. It's not differentiable at C. It's undefined. So we have that hard peak. So if you see the hard peak in both B and C, we're looking at the undefined case. So you could have an undefined and have a max or a min. Also, the converse isn't true. Just because F prime of C equals 0 at a value doesn't mean it's going to be a local max or local min. A couple examples. Well, one example is D. So there's no local extreme at C, even though the derivative at C is going to equal 0. A good example of that would be x cubed. So, this looks like it may be a cubic function anyway. Let's give it a try here. So x cubed, we take the derivative of x cubed, it's 3x squared. So it goes through 0. So in fact, when this equals 0, we have 3x squared, which means that x has to equal 0. But we know that there's no local min or max there because the graph of this looks like this. So neither a max nor a min at the point 0, 0. Okay. So when you have undefined, so this is a critical point there, but it's not a max or min. The other type of critical point is called a point of inflection, which is the change in concavity from concave down to concave up. That's certainly a way. All right. So let's scroll down and do a couple problems from your book. All right. So these problems are on page 377 in your book. This is on page 377. All right, so the instructions say, for the following exercises, find the critical points in the domains of the following functions. So I'm going to take the derivative here. So this is 12x squared minus 3. All right, so we can't get it undefined. So the only other option is having f prime at some value of x being equal to 0. So I'll set this equal to 0. And now I'm going to solve for x. So I'll move the 3 over, and I'll just do this, 12x. So I've added 3 to each side, and I've swapped sides as well. And then when I divide by 12, that reduces to 1/4. So when we take the square root of these, it's plus or minus the square root of 1/4, which is equal to plus or minus 1/2. So here we're going to have the critical points of x equals 1/2 and x equals negative 1/2. For 111, we do the same thing. We take the derivative. So the derivative of the natural log is 1 over what the natural log is of, multiplied by the derivative of the interior there. So it's going to be 1 over x minus 2 times the derivative of x minus 2, which is just 1. So I'm left with y prime over x minus 2, which can never be 0. The only way to have a function equal to 0 is if the numerator is equal to 0, and this doesn't have that. But we can find where it's undefined. So, y prime, or I guess f, is undefined at x equals 2, right? Since 1 over 2 minus 2 equals 1 over 0, which is undefined. All right, but is 2 an answer? So in the instructions it says, for the following, find the critical points in the domains. So we're looking for in the domains of the following functions. Well, let's check out f of 2. So not f prime of 2, f of 2. I guess f prime is undefined at f prime is undefined at x equals 2, not f. Sorry, it will also be undefined, but we'll do that now. So f at 2, not f prime at 2, is going to equal the natural log of 2 minus 2, which is the natural log of 0. But the natural log is not defined at 0. So the domain of ln, or domain of ln of x, is 0 to infinity. So there is no solution to this, or at least no critical values. So no critical points for this problem. All right, I will make another video doing a couple more of these problems, and I'll post it in a bit.